Hello everybody, welcome to Psych Academy. This is Arko sir, and today we will be having a full class on types of reasoning from Unit 6 Logical Reasoning UGC Net Paper 1. The types of reasoning is the starting point for the entire unit of logical reasoning. We will have to understand the differences between deductive reasoning, inductive reasoning, how exactly the logic flows, differences between soundness, cogency, validity, invalidity, and how it flows not only through deductive and inductive reasoning, but through other kinds like conductive, abductive, analogical, all of it. So let's start. Today we will be discussing mostly this particular area from the syllabus, distinguishing deductive and inductive reasoning with other kinds of reasoning. First, we get to the structure of argument. So how exactly is an argument made? An argument is simply a kind of, not a proposition, a passage that is described that these are the basis or the information that I have. Based on this, I am proposing this kind of an argument or hypothesis or conclusion. How exactly does it work? First, you have the statements or propositions. Proposition is a statement that can be proven to be true or false. Premise 1, all birds have feathers. Premise 2, penguins have birds. Conclusion, penguins have feathers. Very simple example. So in this case, these two are the ones that are given to us. This is the base, the initial information that we are starting from. That is the premise, the reasons to support an argument. And the third point, the conclusion, this is not given to us. This is what we are making based on the premises, that is, if all birds have feathers and penguins are birds, penguins have feathers. Now, it may look like that this is so intuitive that yes, penguins have feathers. But the point is, instead of penguin, if I just had thought of any other bird, let's say I talk of a grebe. Now you may not even know that what a grebe means. The moment I tell you that a grebe is a bird, that is, grebes are birds, and all birds are feathers, you can make at least one conclusion that grebes have feathers. So when we take the penguin example, it is very relatable, very easy to understand that why do we even need a kind of reasoning venture. But when you have other kinds of information about which you do not know very well, then reasoning becomes extremely important, and which is what is required in any kind of research or inquiry. So another examples, premise, tigers are stronger than humans. Premise 2, tigers have sharp claws and teeth for attacking. Premise 3, tigers can be very aggressive. Conclusion, tigers are dangerous for humans. Now, what is the difference between this example and this example? Out here, these two premises, all birds have feathers and penguins are birds. I'll erase the Greek for now. And penguins are birds. These two premises are interlinked. What is the common link? This one, birds. This is considered the middle term. We'll get to that. But this is linking the two premises together. But out here, even though we have a link in tigers, the premises are not directly linked to each other. Tigers are stronger than humans. Tigers have sharp claws and teeth for attacking. Tigers can be very aggressive. Hence, they are dangerous for humans. And the conclusion, dangerous for humans, is supported by taking all of the independent premises together. Out here, these two premises are very closely linked. These are not very closely linked. And there is one another difference is that out here, there is an assumption made which is not directly flowing from the premises. Tigers are stronger than humans, have sharp claws and teeth for attacking, and can be very aggressive, right? Now, the point is, in all of these, there's an implicit assumption. Anybody who is stronger than humans can be dangerous for humans. Anybody who has sharp claws and teeth can be dangerous for humans. Anybody who can be very aggressive can be dangerous for humans. These implicit predictions are already made. Now, one of these predictions, and by the way, Each of these predictions are by themselves not enough. So, for example, I can say instead of tigers, I can say that, let's say, gorillas are stronger than humans, but we may not consider them to be very dangerous to us. Similarly, tigers have sharp claws and teeth for attacking. Well, same for rats. Rats can also have sharp claws and teeth for attacking, but we don't really consider them very harmful to humans in the attacking sense of way. Tigers can be very aggressive. Well, we can also say that toddlers can be very aggressive. That also does not necessarily mean that toddlers are very dangerous for human beings. So the point is, each of these premises independently may not be very strong enough, but in combination, they have a good strength where we draw the conclusion tigers are dangerous for humans. And another point is, we are assuming aggressive means dangerous. Having claws and teeth means dangerous. Stronger means dangerous, even though that is not written in the premises. Out here, in this example, everything is within the premises. You do not require any other kind of knowledge, any other kind of information. That's it. You just know the premises, you get to the conclusion. Out here, this is not the case. So this is the two bases of reasoning. If we get this, all the rest of reasoning is very easy. That is, in certain kinds of reasoning, the information, the conclusion directly flows from the premises. In certain kinds of reasoning, the information is just likely and we may need to form other kinds of assumptions. For now, we will focus mostly on the first kind, that is deductive and inductive reasoning. We will delve into the other kind a bit through conductive and abductive reasoning. So argument is simply a group or collection of propositions plus conclusions. It is propositions or group of premises plus conclusion. Only conclusion does not make an argument. Only proposition does not make an argument. They have to be combined together to make an argument. That is, tigers are dangerous for humans. Conclusions are common to the whole group or all premises. Each premise individually does not have a conclusion. The two kinds of reasoning, deductive and inductive. Deductive goes, so let's look at the example first. All men are mortal or no men are immortal. David is a man, hence David is mortal or David is not immortal. So we are starting off from a larger category going to a smaller specific instance, all men. And understand both of these are universal, that is all men, yeah, all, but no men are immortal, that is there is not a single man who is immortal. For this also, it assumes information about all men that there is, that you have studied all men and found out that none of them are immortal. So even when the statement starts with no, it is still talking about an universal category. No, none, and all about universal categories. So premises are major or universal. This is the major premise, the larger category. Minor or specific, this is the minor premise or the smaller specific instance. Conclusion, David is immortal or David is not immortal. Deductive reasoning, they will always be using all or none statements. It goes from general one to specific conclusion, from a broad to specific conclusion. Inductive is not that kind. In this case, we are doing the opposite. We are starting from specifics, going to a general conclusion. Example, premise 1, John is stressed out before exams. Rita is stressed out before exams. Raj is stressed out before exams. Conclusions, exams are stressful. Now the point is, now let's try to compare this with the kinds of reasoning that we already discussed. First of all, we are going from individual instances to a larger category. So from specific to broad, specific to general conclusion. Hence, this is important. Hence, this is the opposite of deductive. The other point is in deductive. Since we knew about all instances, making the claim was universally valid. If all men are mortal and David is a man, David has to be mortal. If no men are immortal, David is a man, David cannot be immortal. But out here, John stressed, Rita stressed, Raj stressed, it is entirely possible that these three happen to be more stressed out in general, or these three have not studied or not good in their particular subject. Because we, after all, do not have information about the entire group, about all instances like we have in deductive reasoning. So deductive reasoning guarantees a true conclusion as long as the premises are true and reasoning is valid. Inductive reasoning, even with a very valid way of reasoning, it will never guarantee a true conclusion with true premises also, because it is not talking about every instance. It is possible that whatever we are looking at is simply an atypical subset or somehow not matching the entire population. Another important part is, so out here you can also state that, sir, here is we see all three of the statements, premises, all have to combine to form the conclusion. Yes, that is true. But see, each of the premise stressed out before exams, stressed out before exams, all directly linked to the conclusion. You are not having to make any kind of extra assumption. You are simply seeing that there is a high number of people who are getting stressed out, hence exams are stressful. But in the conductive reasoning, in this part, I'll remove gorillas, rats, and toddlers. In this part, you had to make an added assumption that being stronger leads to danger for humans. Having sharp claws and teeth leads to danger for humans. Being aggressive leads to danger for humans. You still had to have these implicit assumptions, which out here, you did not have to do that. Inductive reasoning. Because exams, stressful. This is the difference between inductive and conductive. Please understand that even though in inductive reasoning, we are not able to directly conclude that yes, this is 100% true or 100% false. It does not mean that we are going out of the premises. We are not making any assumptions that does not require the premises or that requires our pre-existing knowledge or anything like that. It flows from the premises only. That's inductive reasoning. So, inductive specific to general, deductive general to specific, and we need both kinds of reasoning. A simple example would be that, let's say you are studying a group of patients, or you want to study people who have anxiety. Now that you want to study that, you cannot study each and every person on the world who has anxiety. So what do? You take sample. Now a sample is made of individual observations. This is what makes a sample. Now you see that all of these individual observations, you give them a benzodiazepine, benzos, then what happens is their anxiety is reduced. So from this number of instances, what did we learn? We made a conclusion about a larger population that everybody who has anxiety can benefit from getting benzodiazepines as a treatment, from specific to general category. Now, when a psychiatrist who has already learned these studies, learned these theories, when the psychiatrist is starting from the general theory, that is, everybody who has anxiety can benefit from benzodiazepines. This is what the psychiatrist is starting from. And then when a client comes, that's for that one particular instance, psychiatrist states, okay, you have anxiety. I am prescribing you benzodiazepine because it will be helping you. So we first use inductive reasoning from instances to get to a general law. Then we use the general law to use that, and from the general law to make conclusion about a specific instance, that is deductive reasoning. In our practical life, we are going on using both of them. The types of premises that we have, major premise gives information about a larger category, like all or none statements. For inductive, it would be most or some or few statements, because inductive does not discuss all instances. That is why inductive cannot guarantee a true conclusion. Minor premise gives information about a specific instance within the category. Let's look at some examples. Major premise, all mothers have child. This is the deductive version. Minor premise, Sheetal is a mother, hence Sheetal has a child. Major premise, no tiger eats grass, which means you know that all tigers, you have studied all tigers and seen that none of them eats grass. So, Remy is a tiger. Conclusion, Remy does not eat grass. This is a minor premise. Minor means one single instance. So, major means large instance. Then you get the conclusion. Same thing, but for inductive, we do not have all or none statements. So, major premise, most students are footballers. Minor premise, Kabir is a student in single instance. Conclusion, Kabir is a footballer. Now understand, this is mostly likely to be true. It can never be guaranteed. Because even if you say that most students, instead of footballers, you can say something else also. That most students are young. This we can say that you just look around, most of the students that you have, they happen to be young, right? Or most students are at least younger than 40 years old, right? But the point is, that does not mean that Kabir, who is a student, has to be younger than 40 years old. It is entirely possible that Kabir is somebody who is older than 40 years old. You have some atypical instance where somebody is continuing their education, maybe has taken a lot of time to do their PhDs, whatever be the case, come back to study. So, in inductive reasoning, even with a very strong major premise like most, you can never guarantee a truth. Other examples, major premise, few students are fit footballers. Minor premise, Kabir is a student. Conclusion, Kabir is not a footballer. Now, in this case, even though you see few, is it still a larger category compared to Kabir? Because Kabir is just one instance, one singular instance. Few means at least you are talking about 5 to 6 or at least more than one. So you don't have to focus on whether it is talking about few or very little or only some, or if it is says no, none. As long as it is a larger category from the other premise, it is a major premise, and the one that talks about the singular instance is the minor premise. You get asked questions like this, you are asked to identify which is the major one, which is the minor one, and only if you understand major premise, minor premise, can we move on to major and minor terms, which we will be going to in syllogisms. Now, a bit of a deep dive into deductive and inductive reasoning. Deductive reasoning, so let's try it. Premise 1. Maharashtra is bigger than Mumbai. Premise true, Mumbai is bigger than India. Conclusion, Maharashtra is bigger than India. Okay, this doesn't really sound correct. Maharashtra bigger than Mumbai, okay. Mumbai is bigger than India, no. And Maharashtra is bigger than India, again, no. We know India is much larger, so this does not really ring true. So let's try another example. State if the conclusion is logically correct or incorrect. A is bigger than B. B is bigger than C. A is bigger than C. Yeah, this makes sense. We can even draw it out. A is bigger than B. So if this is B, we can say this is A is bigger than B. B is bigger than C. So if B is this, we can say C is this. B is bigger than C. Then we can easily see A is bigger than C. This is coming out to be correct. We can draw a Venn diagram like this. That is A is bigger than B and B is bigger than C, which automatically means A is bigger than C. So this is correct logically. We are getting the conclusion. But you see, it has followed the same format. Maharashtra is bigger than Mumbai. So if we say Maharashtra. So we write Maharashtra is bigger than Mumbai. So okay, this is for Mumbai. This is for Maharashtra. Mumbai is bigger than India. Mumbai itself is bigger than India. Then Maharashtra is bigger than India. Logically, this is following. This is the point of logical correctness versus truth of premise or conclusion. Truth or falsity, it means, is it true in the real world. But logical connections, it does not discuss about the truth in the real world. Given the premises that are there, is it logically correct? If we assume that the premises are correct, then is the conclusion logically valid? Yes, in this case. Hence, this is a logically correct solution, logically correct conclusion. And these questions are abound in the examination papers. They will intentionally give you statements which does not make sense in the real world, but logically they are being valid, and you have to find out the logic rather than simply whether or not it is true in the real world. Premise 1. Throwing a feather at a glass will break the glass. Premise 2. Jai throws a feather at a glass window. Conclusion, window has broken. Regardless of the fact that we know you cannot just break a window by throwing a feather, if we assume the premise to be true, then yes, throwing a feather at a glass will break the glass and Jai has broken the window. So the conclusion is true here. That conclusion is logically correct. This is called validity. Valid versus invalid logic. Validity is equal to whether or not the conclusion follows from the premises. And one important thing, by the way, please remember that even though you logically understand these things, and they are simple things, they are not very complex things to understand, but you also have to remember the definitions, okay? Because sometimes what happens is I've seen students that they understand it very well and they are able to conclude in their own ways, but they have not learned the definitions, and hence in match the following questions or in statement questions, sometimes they are making mistakes. So please remember, definitions are also very important. Validity, conclusion follows from the premises. Truth, premises are true in the real world. Logical truth and material or factual truth. So logical truth is validity of argument, same as validity. And the normal truth that we are talking about is called material or factual truth, real world truth or falsity of the statement. Truth and material truth is the same thing. Logical truth and validity is the same thing. Now, let's look at some of examples of valid versus invalid reasoning. Premise 1. All birds are feathers. Premise 2. Penguins are birds. This part has been given to us. This we will assume to be true. Valid reasoning, penguins have feathers. Yeah, all birds are feathers, penguins are birds, penguins have feathers. This is correct. If we say penguins don't have feathers, it's the invalid reasoning. We are clearly saying all birds have feathers and penguins are birds. Then if we say penguins don't have feathers, it does not make sense. So this is invalid. Similarly, see, penguins can fly. It seems like that it is valid because it is actually true. Penguins can, look at the other one. Penguins cannot fly, right? Penguins cannot fly. It seems like it is true because actually we know the penguins cannot fly, but is it valid? Do the premises provide information about flight? They talk about feathers, but they have not stated that feathers is equal to flight. That is not given anywhere in the premises. So if we say that penguins cannot fly, that even though is true in the real world, does not follow from the premises. Premises does not talk about flight. So in terms of reasoning, it is also invalid. And penguins can fly. Does the equation talk about feathers leading to flight? Any kind of flight? No. So this is also invalid. Understand? If it does not flow from the premises for whatever reason, in whatever way, it is invalid, even if it is true in the real world. And if it flows from the premises, it is valid, even if it is false in the real world. The same example that we have discussed. Reasoning is valid, that we have already established. Reasoning is valid. Premises are not true. Premises are false. Hence, the argument is not sound. Sound means that it is perfect, that it is something that we can count upon, that we can bank upon, rely on this particular argument. So, without true premises that are not true in the real world, even valid reasoning will give you a false conclusion, a conclusion that is not true in the real world, false in the real world. So, false premise plus valid reasoning is equal to false conclusion, and it is not sound, it is not perfect. Similarly, Maharashtra is bigger than Mumbai, Mumbai is bigger than India, Maharashtra is smaller than India. This does not work because we are drawing it. Maharashtra is bigger than Mumbai, so we take this to be Mumbai and this to be Maharashtra. Mumbai is bigger than India, so the small version is India. Then Maharashtra, this large line, how can it be smaller than India? It cannot be. Even though this is true in the real world, does it flow from the premises? It does not. So logic or validity is not there. So even the conclusion is true, if premises are false, only invalid reasoning can lead to a true conclusion. This is a false premise. This is a true conclusion, and you cannot get a true conclusion from a false premise using valid reasoning, because valid reasoning flows from the premises only. So once again, argument is not sound because reasoning is not valid. Even if conclusion is true, even if premise, one of the premises is true, reasoning is not valid. So to get a sound argument, you need both true premises, that is correct information, and also valid reasoning or logic, that is ways of using your reasoning. You need both. For deductive reasoning, and again, this definition is very important. If premises are true and logic is valid, conclusion is guaranteed to be true. Premises are true, conclusion follows from the premises, it has to be true. Hence, argument will be sound. Unsound argument means it either has a false premise, basically anything that does not follow this criteria. It either has false premise or invalid reasoning or logic or both. So let's look at examples of some unsound arguments. So soundness, first one is sound. All humans need oxygen to survive. This is true. Mary is a human. Well, we'll consider it true. Hence, Mary would need oxygen to survive. This is also true, and the reasoning is valid. True premises, valid logic, sound. This one. All humans need carbon dioxide to survive. Premise itself is false. Logic is valid. Mary is a human and hence Mary needs carbon dioxide. But premise is false, hence unsound. All humans need oxygen to survive. Okay, true. Mary is a human. True. Mary does not need oxygen to survive. This cannot work. That is, this is invalid because you are talking about everybody needing oxygen. Mary is a human. Then why would not Mary need oxygen? So invalid logic. Once again, this is unsound. All humans need oxygen to survive. Mary is a cat. Okay. Mary needs oxygen to survive. We do not know if cat and humans are the same. Information is given about humans. You are making another information is about a cat, and you are making a conclusion about a cat from information about humans. The premises are not even linked. This one and this one do not even have a link with each other. So unsound. It has to be invalid logic. All humans need oxygen to survive. Mary is a human. Okay. Mary needs carbon dioxide to survive. The question, and once again, it is not about our own knowledge that carbon dioxide is not required to survive. Even if instead of carbon dioxide, I had written Mary needs water to survive, the conclusion would be true. Mary would needs water to survive. But does the premises talk about water? It does not. It talk about oxygen and human beings. It does not talk about water here. So even the premises are true, conclusion is not linked to the premises. So this is invalid logic. This is also unsound. Remember, whenever there is a gap in link, or the premises are not linked to each other, or conclusion is not linked to the premise, it is all part of invalid logic only. Deductive fallacies, that is sometimes when we use our logic in problematic ways. Example, so see the major premise in all the four situations is the same. All mothers have a child. In the first one, minor premise, you are a mother, hence you have a child. This is valid. Because if all mothers have a child, you are a mother, you have a child. This is the set of mothers, and you happen to be somebody here. All mothers have a child. You do not have a child, hence you are not a mother. Is also correct, because if all mothers have child, without the child, how can you get into this criteria? You are not a mother. But all mothers have child. You are not a mother, as if you do not have a child. This is invalid. You can easily be a father. You can have a child while not being a mother. Again, all mothers have a child. You have a child, hence you are a mother. No, again, you can be a father. This is called the fallacy of a single cause. That is, while the premise tells you that all mothers have a child, what it does not tell you that all children or everybody who has a child is a mother. That is not what it's talking about. This is called the fallacy of single cause. That is, having a child, it can come in two ways. That is by being a mother or by being a father. This is called the same effect having multiple causes. So while you have information about one cause, you don't have information about another cause. That is called the fallacy of single cause, assuming that everything can be caused by only one thing and hence making inference based on that. Only if you understand that all mothers have a child, so you are not a mother. Even without being a mother, you can have a child. There's another route to having a child. Then we understand that this is not valid reasoning. So this is invalid reasoning. Propositional or conditional reasoning is a kind of deductive reasoning only, where we take the same format, but we take an if-then format. So look at this. All mothers have a child, you are a mother. Now I am simply like taking this part and combining it into one statement. That is, example, if you are a mother, then you have a child. And then you are a mother, you do not have a child, you are not a mother, you have a child. The same like the earlier table, exactly the same. It is just that you have combined that all mothers have a child. Instead of that, you stated if you are a mother, then you have a child. Propositional or conditional reasoning has a P to Q format. That is, if P, then Q. If you are a mother, then you have a child. Let's do another example. If students eat pizza, then they score high on their exams. So if students eat pizza, this is P, then they score high on their exams, this is Q. Following the format, if P, then Q. For all of them, premises is same. Once again, we'll just do a revision of whatever we already have done. If students eat pizza, then they score high. Minor premise, John has eaten pizza. Conclusion, John will score high. Valid. If students eat pizza, then they score high on their exams. John has not scored high. Well, if he had pizza, he would have scored high. That is already mentioned. If he has not scored high, which means he has not eaten pizza. This is also valid. If students eat pizza, then they score high. John has not eaten pizza, so John will not score high. This is not valid. Why? Because while it states that eating pizza leads to high score, it does not state that high score can be gotten only by eating pizza. It can be gotten by studying also. It can be gotten by cheating also. It can be gotten by maybe just watching a movie. Whatever, if you can have through pizza, then watching a movie also works. The point is, it states that eating pizza leads to good scores. It does not state that the only way you get good scores is by eating pizza. So this is invalid. If students, again, John has scored high, which means John has eaten pizza. No, he may just have studied. And hence, this is also invalid. This particular calculation that we are doing so that we understand if a proposition is true or false is called propositional calculus. Again, is exhibiting the fallacy of single clause. These parts, modus ponens, modus ponens, is not required right now. All we will be, because we will be covering this separately in the logical fallacies section. Inductive reasoning, no, all, or none statements. Basically, you do not have information about all instances. Hence, it does not guarantee a true conclusion. Conclusions are only likely to be true. Example, most birds can fly. All the major premises are same. Sparrow is a bird, sparrow can fly. Nature of conclusion, true. Canary is a bird, canary can fly. True. Duck is a bird, duck can fly. True. Ostrich is a bird, ostrich can fly. False. You see, reasoning is valid here. So even though for inductive reasoning, we talk about cogency rather than validity, let's still take that reasoning is at least strong out here. It makes sense. If most birds can fly, sparrow is a bird, sparrow should also fly. Most birds can fly, canary is a bird, canary should also fly. But in the same exact format, and while having all true premises, all these most birds can fly, this is a true premise. All of these premises, they are all true. So you have true premises, you have strong reasoning. Still, you can lead up or get a false conclusion. This is why we state that inductive reasoning does not guarantee the true conclusions. It is only likely to be true in most of the cases, not in all the cases, because you don't have information about all cases. It is the kind that leads to new knowledge, obviously. Why? Because the point is, this is how research progresses. In research, what do? We take a sample and then generalize the results to a larger population, because we cannot study the entire population together. So we are starting from small, going larger. We are concluding that as if it will work for everybody without directly knowing that it will work for everybody or not. So inductive reasoning is the one that is used for research. You can also look at it another way, that deductive reasoning requires you to have information about all instances. If you have information about all instances, why do you need to do research? Why do you need to do any kind of inquiry? So, inductive reasoning leads to new knowledge. Research example, John learns better with audio-visual presentations. Mary learns better with audio-visual presentations. Sam learns better with audio-visual presentations. Conclusion, audio-visual presentations help learning in humans. And in all the cases, you see learning and audio-visual, learning and audio-visual. The cause effect are directly linked, which is why we can make the conclusion audio-visual presentation help learning in humans. Argument is strong due to having a lot of observations, a number of observations. Always remember, there's still the possibility that this is simply a group of people who are better audiovisual learners compared to others. That would just be sampling bias. You have gotten a wrong sample or a very vast sample compared to the entire population, but still, it is possible that the sample was biased. You don't get a guaranteed truth from here. Leads to new knowledge. Again, premise 1, Raj got wet in the rain and had fever. Jamal went out in winter without a jacket and had fever. Priya stayed long in a chilled AC room and had fever. Conclusion, cold temperatures can cause fever in humans. Cold temperatures is directly implied in all of these, and it is all of them is linked to fever. So cold temperatures can cause fever in humans. Argument is strong due to high diversity of observations. In this case, in the first one, you had the same observation multiple times. In this case, you had diverse observations indicating or pointing towards the same thing. And this is exactly how research progresses. Whatever we discuss about research, what makes a theory really strong is that research, the findings has to be replicated, right? Again and again replicated. This is replication. That is, same thing is repeated multiple times, and the theory also has to be tested in multiple different situations. This is the diversity part. Different situations you are testing it, your different observations you got, and still getting the same result. A good theory has been both replicated and tried in different situations. This is why logical reasoning is so important to understand research. And which is why you also understand that inductive reasoning is the one that is used for research and inquiry, not deductive reasoning so much. Now, let's discuss some examples of inductive reasoning and try to figure out how it never guarantees a truth value. Major premise, sun has risen every day in recorded history. It is true. Minor premise, April 21st is a day. Conclusion or inference, this is also true. Conclusion or inference, sun will rise on April 21st. It is a true conclusion and the reasoning is strong because we are talking about every day. Higher the number of instances, stronger is the reasoning. Most birds can fly. Most birds means that this is again about strong reasoning. Premises are true. Canary is a bird, ostrich is a bird, true premises. Canary can fly, reasoning strong. Ostrich can fly, reasoning strong. This one becomes true, this one becomes false. Now, true. The true premise, some humans are musicians, this is true. Rahul is a human, again true. Rahul is a musician, saying the reasoning is weak because we are focusing it on some humans. Some humans is not strong. Most humans, almost all humans that we have encountered, these are strong. Some humans is not very strong. So it is a weak reasoning strength. But can we guarantee that weak means that it is a false conclusion? No. Even with only some human beings being musicians, Rahul can be a musician. So it is unknown. Again, let's start with some false premises. Most humans can fly. This is a totally false premise. Rahul is a human. Okay, true. Rahul can fly. Well, reasoning is strong. That is, most humans can fly. Rahul is a human. Rahul can fly. But you have wrong false premises. So again, it is leading towards false conclusion. But does that always hold? Example, most humans eat raw meat. This is a false premise. Seema is a human, true premise. Seema eats raw meat. The conclusion, the reasoning is strong because most humans are eating raw meat. So Seema is a human. So reasoning is strong. But even with a false premise, can we say that Seema does not eat raw meat? Maybe she is one of those few exceptions who does eat raw meat. There are a few exceptions always. So how do we know, how do we guarantee that false premises will directly lead to a false conclusion? We don't know that. False premise, strong reasoning, still it is unknown. Not a guaranteed false conclusion. Again, another example, most humans like chocolate. You have true premises. Seema is a human. Seema likes chocolate. Okay, it is strong because coming from most, it is a strong reasoning. But Seema may be one of those few exceptions who does not like chocolate. And hence we have an unknown conclusion. We don't know if it is true or false. The point is that in inductive reasoning, you can try whatever combination you want to. You can try combinations of true and strong, combinations of true and weak, false and strong. You can even try false and weak. I'll add that one next time. False and weak. Regardless of that, you may still have, you don't know what the conclusion exactly will be. Now, since we cannot guarantee that inductive reasoning will lead to true conclusions, we cannot really talk about inductive reasoning or conclusions being solid. Inductive arguments can't be solid or sorry, sound, that is perfect. We cannot talk about perfect or soundness. So we simply talk about cogency, that whether or not the conclusion makes sense or has a high chance of being true. This is the definition of cogency, so please remember it. Cogent argument is equal to true premises plus strong reasoning or logic. If the premises are true and logic is strong, conclusion has a high probability of being true, not guaranteed to be true. Hence, the argument will be cogent. Uncogent is false premises or weak reasoning slash logic or both. Signs of strong inductive logic, that is, you can look at the statement and understand where we can find strong reasoning. Use of most or almost all rather than some or few. Use of many premises. More premises, which means a lot of instances. So most or almost all is a lot of instances within one premise. Many premises, they just keep on adding to the number of instances. Use of high diversity of premises, like we discussed in many situations, and adding exceptions. Like in this example, that most birds can fly. If we had stated most birds can fly except ostriches, then we would have gotten an even stronger reasoning. And the moment we see ostriches as is a bird, we will simply say ostrich cannot fly because exception has been added here, that is except ostriches. So we will not reach this conclusion, which means our chance of reaching a true conclusion increases, gets stronger. Strength of the arguments can be increased by increasing number of observations, increasing diversity of observations, and eliminating the exceptions, like all birds can fly except ostriches, emus, kiwis, penguins. Some examples of how we, and these are, by the way, I'm given in the questions, like we did in the deductive reasoning. Same for inductive reasoning, you get these kinds of questions, you find arguments, and they are going to ask you, is it cogent? Is it uncogent? Is the logic strong? Is the premises true? These kinds of questions are asked. We will be discussing those in a separate PYQ session. So for now, please pay attention. Premise 1. Most students who study well score well. This is true. Rahul has studied well. We assume to be true. Hence, Rahul will score well. Starting from most, so it is true premises, strong logic, cogent. Most students who don't study well score well. This does not work. This is a false premise we are starting with, hence uncogent. Some students who study well score well. We are starting with a weak logic because it is some students, not most students. So we are starting with a weak logic and hence it is bound to be uncogent. Most students who study well score well. Okay, true premises. Rahul has practiced guitar, hence Rahul will score well. The premises are not connected to each other, which means logic will be weak, again uncogent. Most students who study well score well, okay, true premises. Rahul has studied well, okay. Rahul will be good at music. Conclusion is not linked to premises, so again weak logic. See the difference, and these two, by the way, they are not the same. In the first one, premises are not linked to each other, studying well and guitar. In the second one, premises are linked to each other. Conclusion is not linked to the premises. Studying and score, they are too good, being good at music. All of these examples of weak logic and hence uncogent arguments. A small revision of deductive versus inductive, very often in the questions. Deductive reasoning going from general to specific, from broad to narrow. Top down, because you are starting from a broad category, then going to a specific instance. So top down, in deduction, we talk about validity, soundness of conclusion, guarantees a true conclusion if premises are true. Inductive reasoning specific to general, from few instances, you make a conclusion about a larger category. Bottom up, from the starting from the few, going to larger category. Inductive strength, not validity, understand. Deductive validity, inductive strength. Deductive soundness, inductive cogency. Deductive guarantees a true conclusion. Conclusion only probably true, not certain to be true. It leads to new knowledge. These two last slides are very important. Other types of reasoning or arguments that we have. One is conductive argument. That is, we are weighing multiple independent reasons. This is why it is different from deductive or inductive. Conductive is where you are combining one's independent reasons. They are not linked to each other. Because in deductive reasoning, in inductive reasoning, both, we studied how if the premises are not linked to each other, then automatically logic becomes invalid or weak. But in conductive argument, it is taken for granted at the beginning only that premises do not need to be linked to each other. So, premises can be for or against a topic, conclusion drawn in a convergent way by adding or integrating. So, let's look at some examples. Premise 1. Restaurant has received positive reviews for its food. Okay. Restaurant is clean and pleasant. Restaurant offers affordable prices. Hence, restaurant is a good place. This restaurant is a good place to dine. Now, this conclusion, it has strength only by combining all three of these premises together. Only one of these premises by itself does not have enough strength to ensure that the restaurant is a good place to dine. But you combine them, you get the strength, and they are not directly linked to each other. One is for the food, one is for the cleanliness, one is for the affordable prices. And if you just keep on increasing more premises, it becomes even stronger. Now, let's take another example. With the same, just extending it. Now, when we add a premise against dining, that is a negative premise. To reach the restaurant, you need a 2 hours drive. This point may be strong if the restaurant was only affordable or only had tasty food or only clean. But the combination of premises is decreasing the significance of premise. If I just tell you it has great food but very far away, they can cancel each other out. Clean and pleasant but far away can cancel each other out. Affordable prices but far away. But if I just take all of this, great food, very pleasant, very affordable, plus 2 hours drive away, then you may be saying that the restaurant is good enough to justify the drive. So it is again not about individual positives or negatives. You are integrating it together. You are summarizing it as a whole, which is why it is stated that in conductive arguments, we draw the conclusion in a convergent way together. But if one of the premise is too strong, example, the restaurant is in another country, then the distance becomes extremely strong. And then you are not thinking that, okay, that distance is justified, would be justified by by the food that you get. No, or the ambience or the total experience that you have. No, it is another country. So this one negative premise was so strong it reduces the significance of all the other premises. Similarly, if in a great restaurant that is good in every way, if the seating area is too unhygienic, one negative, or if it is the food is too bad, or if it is too expensive, it reduces the strength of all other premises, no matter how many there are. You may have about 100 reasons for a great restaurant, but one reason that maybe it is extremely unhygienic is enough to just remove the significance of all the other reasons that there is. So conductive argument, the important point is that you are mixing up, converging a series or a set of premises that are independent of each other. They are not directly linked to each other. None of them are individually strong enough, but you are putting all of them together and making an integration or summary of the conclusion. So its differences with deductive or inductive is that no single premise in a conductive argument guarantees the conclusion. In deductive reasoning, you have all or none statements. One single premise is extremely strong. Premises do not work together to form a single logical chain. Instead, each provides a separate, non-decisive reason that gains or loses strength only in combination with others. Please remember, conductive is neither deductive nor inductive. Now we get to abductive. So abductive is very similar to conductive, only in abductive you have to make some assumptions that were not given directly in the premises. Example. So let's look at the examples first, then we get to the definitions. The grass is wet in the morning. Okay. It did not rain last night. The sprinklers are set to run early. Sprinklers are those little things like, you know, these little things on the grass and they just keep on spreading water all around. They are set to run early in the morning. Hence, the grass is wet because the sprinklers are on. It could have been something else also. Maybe somebody just spilled water onto the grass or something like that. Or maybe it is not rain at all, but very heavy dew or moisture that has accumulated. It can be anything. But the point is, we are simply making a connection based on what is the most likely one. Because abductive argument assumes that we do not have all the necessary information. In fact, information may just be not sufficient. Hence, what do? We make educated guesses. We make guesses based on the assumptions that we already have. It requires us to make assumptions that is not already present in the premises. Let's take another example. So what was the assumption here? That there was no heavy fog, or there was no possibility of somebody spilling the water. That assumption was made here. Let's take a few more examples. The living room is messy. Few toys are lying here and there. The cushions are on the floor. There is a school bag on the couch. Conclusion: children were playing here. It requires you to make the assumption that children often leaves the room messy and do not organize their things. It requires you to assume that adults do not play with toys and adults do not put cushions on the floor. So much of your knowledge is required out here. Another example: parent is late from work. Today is Diwali. On Diwali, there is a lot of traffic jams. Conclusion: your parent is stuck in traffic. You make the assumption that your parent had left work at the same time that they do every day. That is your knowledge that you are using. The teacher asked if you are okay. You were unable to pay attention in class even though you usually do. Conclusion: teacher noticed your behavior was different. It can also possibly be that somebody else stated that your behavior, that you are not okay. Or maybe they have already received a phone call from your parent that, my child is kind of sick. They still went to school, but I would suggest to not put any home or scold them for not doing the homework or anything like that. So in this case, we are assuming that nothing like that has happened. It is just the educated guess. Teacher asked you if you are okay. You were unable to pay attention in class even though you usually do. 3. The teacher noticed your behavior was different. They already asked about it and stated that I noticed. Conclusion: teacher is sensitive and emotionally intelligent, which means you assumes that your knowledge tells you that paying attention to somebody's behavior, being able to notice it, is a sign of sensitivity and emotional intelligence. That is where your knowledge is coming in. Another example: John has fever, cough, and sore throat. No other severe symptoms are there. Conclusion: John has the flu. Based on the information that you have. See, in the premises, they have not told you what exactly are symptoms of the flu. It is your knowledge that tells you what is the symptom of the flu. So, it is a type of reasoning that forms a likely explanation for a set of observations. Please remember, abductive arguments, conductive arguments, you require a set of observations. It is not just one kind or just two statements linked to each other. To find the most reasonable explanation based on your existing knowledge, when we do not have all the facts, this is an assumption already made. That is, we do not have all the facts. It is also called educated guesses, seeing effects, then trying to figure out the causes, not going from cause to effect. You look at the effect, then you go for the cause. It generates hypothesis, not deductively valid, because that's the point. It is not valid because hypothesis is made based on available data, right? And hypotheses by definition are not valid. You have to do an entire data collection, then statistical analysis to check if your hypothesis is valid or not. So hypothesis by definition is not directly valid. It is simply a prediction based on your knowledge and experience. So it generates hypothesis which later needs to be verified through data and through statistical analysis. It is not deductively valid. You don't know if it is true. Truth of conclusion is probable, not certain. Still, it does not make it inductive. Neither deductive nor inductive, because in both deductive and inductive, you have the conclusion flowing directly from the premises. You do not need to think of or use your general knowledge at all. It has to flow from the premises. It makes assumptions that are not present in the premises. Then we have analogical argument. Analogical argument simply means comparing based on similarity. Analogical, by the way, is a type of inductive reasoning because it follows directly from the premises. Let's look at some examples. Elephants are mammals, dogs are mammals. Elephants have lungs. Conclusion: dogs have lungs. See, dogs have lungs, information about lungs, which is possessed by elephants, and the dogs are similar in category to the elephant, this part is already mentioned in the premises. So in analogical argument, just because the conclusion flows directly from the premises, it is part of inductive reasoning. It is not conductive, it is not abductive, it is inductive, but it cannot be deductive because it does not have a guaranteed true conclusion and does not have information about all instances. So analogical arguments are inductive in nature. Another example, Raj is fit and athletic. John is fit and athletic. This is the similarity, the link between the two. Raj regularly goes to the gym. Hence, I conclude John regularly goes to the gym. Now, the point is, in analogical argument, just the comparison is not enough. You also have to focus on if the comparison is relevant or not. Out here, fit and athletic and going to the gym are related, relevant. Mammals, that is being of a particular category and having a kind of physiology, is related. But in certain instances, what happens is they are not related. Let's look at the other example. Joanna is very tall. Let's say, okay, this one. Joanna is very tall. Ria is very tall. Joanna likes to play the guitar. Ria likes to play the guitar. You see, the analogy works. Very tall and very tall linked. So Ria is supposed to behave like Joanna. But the comparison does not have relevance. Being tall and playing guitar are not related to each other. Hence, reasoning is weak out here. And once again, we discuss strength in reasoning in strong versus weak in strength because it is a kind of inductive reasoning. Out here, Joanna is very tall, Ria is very tall. Joanna likes shorter chairs to sit at the table. Ria will like shorter chairs to sit at the table. This is strong reasoning because tall, being tall, and sitting at the table, or what kind of chair you like to sit at the table, they are related. They are relevant to each other. But being tall and playing the guitar, they are not related to each other. And you see the comparison out here is also correct. Tall and tall. If Ria was short, then this comparison would not work and it would be weak reasoning. Premise again, Joanna is very tall, Ria is very tall. Joanna likes shorter chairs to sit at the table. Ria will like taller chairs to sit at the table. Even though there is a good enough link, even though there is a good enough comparison, and the comparison that is tall is after all relevant and related to height of chair to sit on, but you have used the comparison in an improper way. It started shorter, that is Joanna and Ria is similar. Joanna acts in one way, Ria acts in the opposite way. So once again, a weak reasoning and hence not cogent. So for analogical argument, you have the same kinds of cogency as for inductive. True premises plus strong reasoning. Strength of analogical reasoning depends on number of similarities. The more similar that you have. So for example, we say elephants are mammals, dogs are mammals. With mammals, if we also add that they are both four-legged animals, they are both land animals, then what happens is possibility of and they both live in packs and herds. The more similar it is, the better is the comparison. Because elephants are mammals, I can also write that whales are mammals. But elephants have legs, whales have fins, elephants live in land, whales live in water. Number of similarities is not very high. But with dogs, number of similarities with elephants is very high. For whales, if I use dolphin, then these two have a lot of high number of similarities. So the more is the number of similarities, the more is the strength of reasoning, the significance of the similarities in the context. Like Ria and Joanna being tall has got nothing to do with them playing guitar. Other examples of analogical argument, these come in the questions. They ask you which kind of arguments they are, what is the kind of reasoning. Busy as a bee. Life is like a box of chocolates. Like finding a needle in a haystack. Human brain works like a computer. Every time a direct comparison is being used, it is an example of analogical reasoning. Finally, we have circular argument or circular reasoning. This is actually a kind of deductive fallacy. This is called circular because you are just moving around in circles from one side to the other. Example, I deserve to win the competition. Why? Since I am the most deserving candidate. The machine works. Why does the machine work? Because it is efficient. How do you know it is efficient? It works. Another example, think of a parent telling a child, you have to do this because I tell you to do this. Why are you telling me to do this? Because it is the right way of doing things. How do you know it is the right way of doing things? Because I am telling you to do that. Going circular. Why am I saying it? Because it is right. Why is it right? Because I am saying so. It is just going on in a loop like this and hence called a circular argument. Example, how do you know this is fair? Because it is moral. How do you know this is moral? Because it is divine. How do you know it is divine? Because it is fair, going back to the first step. So circular argument, by the way, does not necessarily have to have only two factors out here. You see here we have three factors: fair, moral, divine. We have three factors working. That can also lead to circular argument. We can have four factors, we can have five factors. What you really have to look for is that the final conclusion comparison is getting mapped back to the first conclusion. That means it is for now going round and following a full circle. This is how you identify a circular argument. And as you can understand that it is not really getting into any logical view. So it is a deductive form fallacy, a kind of informal logical fallacy. We will discuss fallacies in more detail, where error lies in the content of the argument, how exactly it is presented, rather than the form. Because this machine works because it is efficient, and it is efficient because the machine works. Instead of that, if I just say that the machine works because it is efficient, how do we know it is efficient? Instead of saying the machine works, we can simply say, look at the productivity data, which means the format is okay. The exact content is the problem. We will do formal and informal fallacies in more detail later in the coming classes. Other examples of circular reasoning, but the idea is that assumption makes an implication about the conclusion. Conclusion uses the same assumption as a proof. That is, it does not have an external criteria with which it can be compared. As students of psychology, you would already know that the definition of validity is that it needs to be validated with an external criteria. Out here, there is no external criteria. Thank you, everybody. Our batch is starting on 9th August. It is an online live batch. It will have full syllabus coverage, live and recorded classes. Recorded classes will be available till 1 year of the course beginning. We will have weekly mock test and unit-wise mock test. There's a detailed video about the entire plan also. I will link it in the description. Concept clarification, to the point study material, solved papers and exam strategy. These don't need to be mentioned. Exam strategy is that I will be personally helping each and every student to come up with their preparation based on their strengths and weaknesses and how much time they can devote to studying. The full course fees is 2499. For the first 10 students, it is 1999. This is the number that you have to text, or you can mail at psychacademyofficial@gmail.com. Please remember, it is Psych Academy, not Psycho Academy. Psych Academy official@gmail.com. And these are the other courses offered. Thank you, everybody. Next demo class will be on higher education. Thank you, everybody.